Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we're going to learn transportation sum based on VAM and MODI method. This particular video will be, will teach us how to solve the problem sum which has an alternate solution. Okay, so any question under transportation when they ask us to solve if there is any alternate solution, this is the video that must be, you should be going through. So in this video, we're going to learn how to solve transportation sum under, Vogel method and Modi method when there is an alternate solution. And in the question, they've asked us to find the alternate solution and get the optimum result out of it. Okay, so let us see how to solve a problem sum having alternate solution. Okay, now the question reads out as, now there are three markets and three factories. Okay, so there are three markets and three factories, and they are giving you the supply and demand. They're asking us to find three things. Number one, test the given solution for optimality and find the optimal transportation solution. So if you look in the question, they've already given us the allocated cost. Okay, they've already allocated and gave you the answers. They're asking us to find the optimality. Remember, when they ask us to find the optimality, it means they've already solved as per VAM method, and they're asking us to get the optimal solution using modified method, Modi method, and find one more optimal alternative transportation solution. So this particular question, they're telling you there might be an alternate solution, so find that, and then comment on the managerial significance of alternate or multiple optimal solution. Okay? So that is just to give a comment after that. Okay, now whenever such kind of sum is given where they've already given you they have already marked and given you the cost, the optimal cost they have given you. Okay, they have allocated the cost and they have given you. So in that case, one step gets lesser. Okay, we don't have to solve as per Vogel method. Okay, they've already given us the IBFS. So now what we have to do basically is check the rim condition, number one. Secondly, we'll start with the Modi method to check the optimality. If it is optimal, okay, then we can directly find the total cost. If not, then we'll have to find something else. Okay, we'll have to do something called as a looping and stuff. Okay, chalo. So let us see how to go about with the solve. Okay, first thing what we'll have to find is we'll have to check where the rim condition. Always whenever they give you already allocated marks, then always the very first thing that you all need to find is check for the rim condition. Okay, so what I'll write here is, number one, I'll check for the rim condition. The rim condition ka formula is basically number of occupied cell should be equal to m plus n minus 1. Now in the question, if you look, see how many allocated cells are there. 1, 2, 3, 4, 5. There are 5 occupied cell. M is the number of rows, which are 3. Number of columns are also 3 minus 1. So 3 plus 3 is 6 minus 1 is 5. So it means it is optimal. Okay, meaning there is no degeneracy. The rim condition is satisfied. Therefore, there is no degeneracy. If not, so we can start with us actual solving. So we'll write here testing for optimality using Modi method. Okay, now again in this question there were market and there is factories, so I will divide this in two parts. I have market and I have factory. Market mein I have x, y, z, so I'll write here x, y, z, and we have supply. And in factory we have a, b, c, and we have demand. Okay, so we will have to basically note down exactly what they are given us. So I'll be just boxing these values first. So I have 6, 5, 12, 3, 2, 7, 5, 2, 8. Supply is 60, 80, 85. and the demand is 75, 110, 40, and the total is 225 from both the sides. Okay, now the allocated value is 6 kilo, it is 35. For 3 it is 25. For 5 it is 40. 7 kilo it is 85 and 40. Okay, this is what was or what is given to us. So now in order to find, as per Modi, we need to find something called as U and V. So I'll have to find U1, U2, U3. I'll have V1, V2 and V3. Using the cost, the formula cost is equal to U plus V. Okay, so basically you have to minus from the cost everything. So now all the allocated, now U1 will always be 0. Now check in this file. Now since there are 2 allocated here in the row, I can find V1 and V2. So cos 6 minus 0 will give you 6. So V1 will become 6. Again 3 minus 0, V2 will be 3. Now using V1 I'll be able to find U2. So 5 minus 6 will give you -1. Now using -1 I can find the value of V3. So 2 minus -1 is positive 3. And now with the help of V2 I can find U3. So 7 minus 3 is 4. So with that we were able to find the value U and V. Now we will check for the change in unmarked cells. Okay, so unmarked cell ke liye what I'll write here is, I will write here cell is equal to the change. We need to find the change for unmarked cell. Okay, so I'm writing here unmarked cells. Okay, for unmarked cells is equal to change which is nothing but cost minus U plus V. So now which are the unmarked cells? First is AZ, okay, where the change is cost, which was 5 minus U plus V. So 5 minus 3 is 2. Next unmarked is BY, where the change is equal to cos 2 minus -1 and V is 3. So that becomes 2 minus 2 is 0. Next is CX, where change is 12 minus 4 plus 6, which is 4 plus 6, which is 10. To 10 minus 12 or 12 minus 10 is 2. And last is CZ, change is equal to change is equal to 8 minus 4 plus 3 7. So that becomes 1. Now looking in your unmarked cell ka values, none of the values are negative. If the sum is, always remember, if all the values are positive, meaning we have an optimal solution. But the thing is, since it has an optimal solution, now I can easily find the value of cost. So in the first part of the question, see, they have asked us find the given solution for optimality, find the optimal transportation solution. So since the solution is optimal, I'll write here since no negative change, comma, it is an optimal solution. Since it is optimal, I can find the cost. Therefore cost is equal to all the allocated. So that will be 35 into 6 plus 3 into 25 plus 5 into 40 plus 2 into 40 plus 7 into 85. okay, which gives you 210 plus 75 plus 200 plus 80 plus 595, which is equals to 1160. So my total cost is 1160 as per the optimal solution. That was the first part. Okay, now they've asked us to find the alternate solution if there is any. See, they told you in the question, find one more optimal alternative transportation solutions. Now the rule, when can you have an optimal solution which has an alternate optimal solution? The rule is, from your unmarked cell, if any value is 0, if any answer ka, any cell ka value will be 0, it means it has an alternate solution. So there is 1 0 here. So from this part, there will be an alternate optimal solution available. So now what we have to do here is, we will create the same table here. First we'll have to create some same table, and then now we'll have to use a different method called as looping. We'll have to loop the cell. So we'll create a table, we will have to loop it, and once we loop it, then we'll again have to use the Modi method and check for this optimality. Okay, so now I'll write here now the B part. I'll write here alternate solution exist since by is equal to 0. Okay, so now we'll have to loop it. I'll have to do something called as looping. So what I'll do, we'll make the same table having the market, the factories, and the demand and supply. I won't require U and V right now. Okay, U and V will be required later on. So first we'll create the same table. So I'll pause the video, I'll make the table, and then we'll continue with the video. Okay, now I have created the same table. We have XYZ supply, demand, and ABC along with these allocated values. Now this is the most important thing. In order to start with the looping, listen to this very carefully. Whether the sum has an alternate solution or whether the sum is not optimal, the looping will have to be in the same order. Okay, now in order to loop under alternate solution, check which cell had the value as 0. Now if I can look here, by had the value of 0. Okay, I wrote in here by is 0. So basically my loop will start from by cell. Okay, so this is my by ka cell. This will be my start point. Now from there I'll have to loop in the sense I'll have to make a quadrilateral, a rectangular, a square. Okay, so my start point will be here. I have to make a closed loop. The loop will always be a closed loop where all the allocated value should be in it should intersect with the allocated value. So what is the meaning of that is, now if I start from here, if I go on top, now this has an allocated value, so I can stop it here. So once I get the allocated, I'll have to move on the other side. So I moved here, again I got an allocated because this has an allocated, so I'll come down. This again has an allocated, so again I will move to the opposite side. So this is my loop ka, I've looped it having this is my square. So you start from the cell which has the value 0, then you make a quadrilateral which should cover up all the, so you go up till you have an allocated. The moment you have allocated, you can move to the other side. Since there was allocated, I came down. Since there again there is allocated, see, I can go further down because there is no allocated here, so I'll have to move to back to the original spot. So this is my looping, this is my loop. Now under the loop, now this is very important, the signs. Wherever was your initial start, okay, so put the sign, this is plus, and now go in alternate direction. So plus, the opposite will be minus, again here it will be plus, here it will be minus. Okay, so we have plus minus plus minus. Now what is the meaning of this? Okay, now once we come to this step, this is very important, right? Minimum negative value. What is the minimum negative value? Negative, this is negative, this is negative. Okay, value in the sense this is 25, this is 40, the one in red which I marked. Okay, so among the two, which is the negative the minimum negative value? The negative value minimum is 25. Therefore change is equals to 25. What does this mean? This means now wherever I can see this plus, 25 will get added to your allocated value. Wherever there is minus, 25 will get subtracted from it. So basically it will be 25 minus 25 is 0, so this will become 0. 35 plus 25, so it will become 60. 40 में से 25 will go, it will become 15, and here another 25 will get allocated. So now I have to create a new table. Okay, that will be again testing of optimality table with U and V column, but with the new allocated values. Okay, so let us see again how to do that. So first what I'll do, we'll make the same table here. Okay, we'll have to create the same table here along with the U and V. So we'll make the similar table here. So first I'll make the table and then we'll see how to go ahead with the sum. Okay. Okay, now I have created this table. Okay, the same table with those original values, and I've added U and V. Okay, now let us see how we will get our new values. Okay, now first we will solve the loop part. Okay, wherever there is addition, remember we add the change to it. Wherever there is subtraction, we will minus the change from it. So 35 was the original with the plus sign, so 35 plus 25 is 60. So here it will be now 60. 40 minus 25 is 15, so this will become now 15. 25 minus 25 is 0, so it's gone. There is no allocation there. And here it is nothing. It was 0 plus 25, so this will become now 25. The others remain as it is. So here it was 40, so which will remain as it is. Here it was 85, it will remain as it is. Okay, since the number of allocation have changed, okay, we need to now search for the rim condition. So I will write here rim condition. So in order to find the rim condition, the rule is number of occupied cell should be equal to m plus n minus 1. 1, 2, 3, 4, 5. Number of occupied cell is 5. Number of rows were 3 and column is 3 minus 1. So it is 5 is equal to 5. Therefore there is no degeneracy. We don't have to do anything extra here now. Okay, chalo. Since there is no degeneracy, we can find the optimality. We can start with the optimality part. So we need U1, U2 and U3, V1, V2, V3. Chalo. U1 will always be 0. With the help of this I can find V1. So 6 minus 0 is 6. Since V1 is 6, so I can find the value of U2. So 5 minus 6 is negative 1. With the help of that I can find now V2, so it will be 2 minus 1 is 3. With the help of this I can find U3, so 7 minus 3 is 4. With the help of negative U2 I can find V3, so 2 minus is again 3. Okay, so once we have done this, now we can directly start with the last part, checking for the cell whether they are matching or not. Okay, so what I'll put an additional paper here to check here. So now for all the unmarked, okay, now we need to find optimality. So for all unmarked cell, so which are the unmarked? I have AY. The first one is AY. Okay, remember the formula is cell is equal to, basically you're finding change is equal to cost minus U plus V. Okay, so for AY the change is cost is 3 minus U is 0 and V is 3. So 0 plus 3, so 3 minus 3 is 0. Next AZ, change is 5 minus 0 plus 3, which is 2. The next is C. Okay, next is CX. So here the change is 12 minus U3 is 4 plus V1 is 6. So that will be 6 over 10, so it is 2. Next is CZ. So CZ के लिए change is cost is 8 minus U was 4 and V3 is 3. So 8 minus 7 is 1. Now since all the values are positive, I can say that since no negative change, therefore it is an optimal solution. Since it is optimal, I can find the total cost. Therefore, the total cost is equal to, now the new values, okay, all the new allocated value. So the new all the new allocated values are 6 into 60. So it will be 60 into 6 plus, the next was 15 into 5. So 15 into 5 plus, the next is 25 into 2. 25 into 2, next 85 into 7. 85 into 7 plus, last one is 40 into 2. So 40 into 2. So 60 into 6, this is 360 plus 15 5s are, that is 75 plus 5, 25 2s are 50 plus 85 7s are 5, 95 plus 42s are 80. You total up, we get the value as 1160. Always remember, for alternate solution, all the values, all the alternate solution will have the same value. It was 1160, this is also 1160. Therefore, initial basic feasible solution is 1160. Okay, so this is how you all had to solve the sum based on alternate solution. So we started off with the first part, we got the value, there was alternate solution because of z, then we did the looping, we got the new value, and then we found the last final amount. Okay, so I hope everyone have understood how to solve the sum based on transportation sum based on VAM and MODI when they are giving you to find optimal or alternate optimal solution. Okay, so I hope everyone understood that. With that, we will be ending this video here. Thank you.